Good afternoon, my name is Jonathan Henry. I'm going to be giving you the video presentation over the first Engi 1331 project. And right now I'm going to be highlighting the important things of what our program covers so that you guys have some basic information. So solar panels. What is a solar panel? A solar panel is a panel designed to absorb the sun's rays and convert that energy to electricity or heat. Need to know, solar panels have classes, therefore the higher the class of the solar panel, the more energy it can produce. Equations to use: energy equals productive land times rate times time times 2.59 e raised to the 6 times efficiency. The 2.59 e raised to the 6 is accounted for because our productive land is in miles and we want to match the units of meters squared in the rate. And then in the variables in Matlab we use PL for productive land, rate is R, T for time. The energy produced is measured in kilowatts. The second equation we use is amounts of energy produced per mile squared, so we divide that energy that we just solved for by the productive land to get kilowatts per mile squared. In AE Grand Challenge, the major challenge that this program addresses is how to make solar energy more economical. Our program was designed to compare two first world countries of choice by calculating how much energy can be produced per mile squared with an option of flat or tilted solar panels. The program also tells the user how much energy can be produced over a certain amount of time with the highest class solar panel of that country in a certain amount of land that they would like to buy. The user is then told which country produces the most energy per mile squared, allowing them to make an accurate decision of which country provides more bang for the buck, meaning more energy production, meaning the rate is higher, meaning that you get more energy production for less dollars. So let's go ahead and go to the code. So here we are, the problem statement. The purpose of this program is to determine which country is more efficient at producing kilowatt solar energy per mile squared, telling us where it's more economical to use solar panels. PL is the productive land, EFF is efficiency, T equals allotted time. E number is the energy produced of each country, BE is the bigger energy between the two countries, ECO is pretty much the economics of the two countries, so which one is the deciding factor, which one produces more per mile squared. And the other variable that we use is choice for the while loop. Countries is for the list of countries. Country number is the choice of the country. Country underscore number is the updated country listing without the first choice. TOF is the decision between tilted or flat solar panels. Area is the area of country 1 or country 2. UA is the usable area that is less than 1.5% of the total area of the country. And then we have class, so it's the best class of the solar panel able to be produced in that country. Row number, text number, raw number. This pretty much, the row number is representative of all the numerical digits, and then text number is the alphabetical digits, and then raw is pretty much both of them combined, the text. And then country row, country text, country raw is also the same thing, but it's for another Excel file that we loaded in. And then R is the rate of energy produced by a solar cell in specific class. So the assumptions you have to make for sure in this program is land available for buying is maximum 1.5% of the total land in the country. The energy is PL, productive land times rate times time times efficiency. 1 mile squared is equal to 2.59 e raised to the 6 meters squared. You already know that. The solar panels bought can only be left in the highest grade able to be produced in that country. So you can only buy the highest grade solar panels in any country. This program will only run if the solar panels are flat or tilted, so it won't run if you exit out of the options. The countries chosen are first world countries. So the class range for flat panels are 1 through 10, and the class range for tilted solar panels is pretty much 1 through any number. Like the problem with there's no problem with our code, just the fact that the only thing that can make the code not work is if you were to go to the Excel file into the flat panel sheet and make a class greater than 10. And the reason why is because our data doesn't go past the class 10 for flat panels, but you can type in any class range for the tilted solar panels. So here we are, we went ahead and loaded up all our XLS files right here. And then our first XLS file of the country land area is countries of the world. We loaded that up, and then we got the text and all that. And we got the same thing for the solar resource energy, the first data sheet, DNI, which stands for flat, and tilt lat is equal to tilted. And our list of countries right here, these countries were not chosen at random, these countries were found online, but yeah, so we had to type them in manually. And then country 1 is the first choice. F countries 2 is equals the countries again, and then countries underscore 2 is now updated without that first country choice. And then they ask for it again, and they F the second choice that you wanted, and then you ask for the tilted or flat. So this is for the first. If you exit out of the tilted flat, it gives you an error, but if you choose flat, then it'll load this. Row T1, you pretty much go ahead and string compare your first decision country 1 to text 1, and then it finds the number of rows, the rows where it's at, and then row C2, string compare the country choice 2 to the text, and then it finds those rows. So now you have indexes of the rows, and then class matrix, you want to go ahead and find those rows in the raw, and then you want to get the second column, and the reason why is because it pulls out all those classes, and we can only produce the highest class solar cell, so then we get the max of that matrix that was formed, and we can get the class 1, and then we do the exact same thing with class 2, and then that's what happens. And then so now that we have Y1 class 2, both of those classes refer to a rates of solar cell production. So since, like we said, that it's very limited for the flat from 1 through 10, so we have these if statements and then these rates increments. They don't increment equally, but you know, they don't go up by 0.5 every time, but that's why we had to put it, so they don't go up like that. And then we'll set R1 to equal to the position of 1 in R, and the same thing with R2. And then let's say if they chose flat, we would do the exact same thing as we did up above, but this time, since in tilted, the better hand is that every increment is by 0.5 for classes, or not for classes, I'm sorry, for the rates. So you can do any class that you want, 1 through any number, and the count would always go 0.5 plus 0.5 plus 0.5, and that's pretty much what it'll do for pretty much R1 and R2. And then we want to ask the user for the efficiency, and then we give a warning if it's greater than 1, which is we want it in decimal form, and then we ask how long they want to calculate it for. It has to be in days. And the row of country string match, we find the rows of the country, and then we go ahead and, like in the file that we loaded of the country of the world with the total land area, we multiply by 0.015, we find those rows in the country with string match, and we get the area of that country in column 2 and multiply by 0.015 because that's 1.5%, and that's available area in 1, and then we do the same thing for country 2, and then we have our while statement. So if you input a wrong number, you know, the PL number is asking you for how much area do you want to buy or purchase below 1.5%, and if you input it less than 0, it's wrong. If you input it greater than the option choices in these two statements, greater than the 1.5%, then it's also giving you a warning, and you have to re-input it. So then we want to convert these measurements back to miles squared, so to meters squared. So we multiply it by 2.59 e raised to the 6th, and then we calculate the energy, and then we have to go ahead and turn those back into miles squared. So we do that right here, and then we do the fprintf statements, and then we calculate the eco1 and eco2, so it finds which how much energy is produced per mile squared right here, and then kilowatts per mile squared, and then you find that, and then you want to go ahead and compare. If they're equal, then it'll fprintf this. If number 2, country 2 is greater than this one, it'll fprintf this. If country 1 is greater than country 2, it'll fprintf this. And then it asks the choice, and you would like to repeat it over and over again. And that's pretty much what it does. So let's go ahead and run it so that you can see. Over here. Okay. So let's go ahead and go Australia and Belgium. And we want to go ahead. Are the solar panels flat? Yes, they are. So times 6.5. How many days? Go 365. And then, so let's go with 1,000. And let's go with 100. So would return no. And then buying land to use solar panels is more economical in Australia. So you see how it says class 10 solar panels for Australia and class 4. Let's go ahead and go to our Excel sheet, and we chose flat, correct? So here's flat, Australia class 10, Belgium class 4. So that worked correctly. Now let's go ahead and go test it one more time. I should have pressed yes instead of no. So let's go ahead and do it one more time. Okay, so we're going to choose United States and Portugal. Let's see where it's at. Right here. And then we're going to go with tilted. And we're going to do the exact same thing. So 0.5, how many days? 365, or any day you want really, 1,000. Let's go with 100. So then you have this right here, class 13. Solar panels for the US. Let's go and check it. Yep. And then Portugal is class 11. So let's go ahead and check it. Class 11, good. And then it tells us that buying land is more economical in the United States because it produces this much more than Portugal. So pretty much it works. Thank you very much. Bye bye.